There is something profoundly captivating about the idea that something might exist faster than light. For over a century, the speed of light has stood as the ultimate cosmic speed limit, a boundary woven into the very fabric of space and time. At approximately 299,792 kilometers per second, light does not merely travel quickly. It defines the structure of our universe. According to modern physics, nothing with mass can accelerate to or beyond this speed without requiring infinite energy. This principle, rooted in Einstein's theory of relativity, has shaped our understanding of motion, causality, and the limits of possibility itself. And yet, despite its foundational status, the question persists: is light truly the fastest thing in existence, or are there phenomena that, in some sense, surpass it? To explore this idea, we must first clarify what we mean by faster than light. In the strictest sense, no object or signal carrying information can locally travel through space faster than light without violating the laws of physics as we currently understand them. However, the universe is far more subtle and complex than a simple speed limit might suggest. There are processes, effects, and theoretical constructs that appear to exceed the speed of light, not by breaking the rules, but by operating outside the assumptions those rules were built upon. One of the most intriguing examples comes from the expansion of the universe itself. Space is not a static stage on which objects move. It is dynamic, stretching, and evolving over time. In cosmology, distant galaxies are receding from us, not because they are moving through space at extraordinary speeds, but because space itself is expanding. At sufficiently large distances, this expansion causes galaxies to appear to move away from us faster than light. This does not violate relativity because the galaxies are not traveling through space faster than light. Instead, the space between us and them is growing. In this sense, the universe itself demonstrates a kind of faster than light behavior, not through motion, but through the evolution of spacetime. Another fascinating concept arises in quantum physics, particularly in the phenomenon known as quantum entanglement. When two particles become entangled, their properties become linked in such a way that measuring one instantly determines the state of the other, regardless of the distance separating them. This instantaneous correlation seems to defy the speed of light, suggesting that some form of connection operates beyond classical constraints. However, it is crucial to note that entanglement does not allow for faster than light communication. No usable information is transmitted in this process. Rather, it reflects a deeper level of reality in which distance and separation behave in ways that challenge our intuition. Theoretical physics also offers speculative ideas that push the boundaries of what might be possible. Among these is the concept of tachyons, hypothetical particles that would always travel faster than light. Unlike ordinary matter, which requires energy to accelerate toward the speed of light, tachyons would require energy to slow down to it. While mathematically consistent in certain frameworks, tachyons have never been observed, and their existence raises paradoxes that remain unresolved. Still, they serve as a valuable thought experiment, forcing physicists to confront the implications of a universe where faster than light motion is not only possible, but fundamental. Perhaps the most captivating proposal is the idea of warp drives and spacetime manipulation. Instead of moving an object through space at immense speeds, what if we could move space itself? In theory, a spacecraft could remain stationary within a bubble of spacetime while the space in front of it contracts and the space behind it expands. This would effectively allow the craft to travel vast distances faster than light, without ever locally exceeding the speed limit. While this concept remains purely theoretical and faces enormous technical challenges, it demonstrates that the constraints of relativity may be navigated in ways that preserve its core principles, while achieving extraordinary outcomes. Similarly, wormholes, hypothetical tunnels connecting distant points in spacetime, offer another potential pathway for faster than light travel. If such structures exist and could be stabilized, they might allow instantaneous journeys across vast cosmic distances. Like warp drives, wormholes remain speculative, requiring exotic forms of matter and energy that have not yet been observed. Nevertheless, they illustrate how the geometry of spacetime itself could enable shortcuts that bypass the limitations of conventional motion. Beyond physics, the idea of something faster than light resonates on a philosophical level. It challenges our assumptions about limits, boundaries, and the nature of reality. Light has long been a symbol of speed, knowledge, and ultimate reach. To imagine something beyond it is to step into a realm where our current understanding begins to dissolve, giving way to new possibilities. It reminds us that scientific knowledge is not a fixed endpoint, but an evolving journey shaped by curiosity, experimentation, and imagination. In the context of human progress, the pursuit of what lies beyond established limits has always driven discovery. From the earliest explorers who crossed oceans to the scientists who unraveled the structure of atoms, breakthroughs often begin with questions that seem to defy accepted truths. The notion of surpassing the speed of light may one day transition from speculation to reality, not by overturning the laws of physics, but by deepening our understanding of them. It is also important to recognize that faster than light does not necessarily mean better or more powerful. The speed of light is not merely a barrier. It is a fundamental feature that ensures the consistency of cause and effect. If information could travel faster than light, it could lead to paradoxes where effects precede their causes, undermining the logical structure of the universe. Any theory that allows faster than light phenomena must account for these challenges, preserving the coherence of physical laws. As we look to the future, advancements in technology and theoretical research may bring us closer to answering these questions. Experiments in particle physics, observations of cosmic phenomena, and developments in quantum theory continue to expand our understanding of the universe. Each discovery adds a piece to the puzzle, revealing new layers of complexity and possibility. Ultimately, the question of whether something exists faster than light is not just about speed. It is about the limits of knowledge and the nature of reality itself. It invites us to explore the boundaries of what we know and to remain open to the unexpected. Whether through the expansion of the universe, the mysteries of quantum entanglement, or the speculative realms of warp drives and wormholes, the idea of surpassing light challenges us to think beyond conventional frameworks. In conclusion, while the speed of light remains the fastest known limit for objects and information traveling through space, the universe offers phenomena that, in various ways, transcend this boundary. These examples do not necessarily break the rules of physics. Rather, they reveal the richness and subtlety of those rules. They remind us that the universe is not constrained by our current understanding, but instead invites us to continually refine and expand it. The pursuit of what lies beyond light is a testament to human curiosity, a journey that pushes us to explore not only the cosmos, but also the very foundations of existence. As we continue to question, to imagine, and to discover, we may find that the true frontier is not just beyond the speed of light, but beyond the limits of our own perception.